In this part, I'm going to go over graphing rational functions, two of them, and then I'm going to do a quick little review of some exponent rules you would have learned in middle school. Okay? All right, so this first one here, I'm going to look at my given function f of x, and I'm going to factor my denominator, which is going to be the difference of two squares, so x minus 6 and x plus 6, and I notice that I can cross out a common factor. So my fully factored function is now 1 over x plus 6. Now immediately I'm thinking we have to have a whole, so I'll deal with that soon. My domain, if I look before I cross out, is going to be negative infinity, comma negative 6, union negative 6 to positive 6, union 6 to infinity. To find the y-intercept, I plug in 0 for x, and I'm doing this into the fully factored one now. So that's going to be 1/6, so 0 comma 1/6. To find x-intercepts, you set the numerator equal to 0. So that'd be setting 1 equal to 0, which will never be equal to 0. So we do not have any x-intercepts. Vertical asymptotes, you set the denominator equal to 0. In this case, my denominator is x plus 6. So my vertical asymptote is x equals negative 6. And then to find the whole, my common factor was x minus 6 that I crossed out. Set that at equal to 0, and you get x equals 6. A lot of my students will write 6 comma 0, but no, you actually have to plug in 6 into what's left, into the 1 over x plus 6, which is going to be 1 over 6 plus 6, which is 1/12. So my whole is 6 comma 1/12. Okay? All right, for horizontal asymptotes, I look at the degrees. If you look at the original or even the fully factored one, it doesn't matter. This is bottom heavy. You'll notice 2 is bigger than a degree of 1. All right, same thing here. If you looked at my fully factored one, a degree of 1 is bigger than, this would be like x to the 0 power, right? So in this case, it's going to be bottom heavy, so the horizontal asymptote for those is always y equals 0. All right, so if I graph all that stuff, I've got y equals 0, horizontal asymptote, x equals negative 6, vertical asymptote. I've got 6 comma 1/12 is a whole, right? 6 comma 1/12. My y-intercept was 0 1/6. That's 0 1/6. I don't have any x-intercepts, so I'm going to make my curve. Make sure to go through the hole, but not actually, right? Draw your arrows. Now, again, if you don't know where to put the other curve, that's fine. You can use your understanding of end behavior with odd powers, or you could plug in a number, like to the left, like -7, or I know where it's going. I know it's going to be in this part of my asymptotes. So I'm just going to draw the rest of my curve there. Okay, so that's it for this first graph. All right, let's do another one. Okay, again, I'm going to fully factor first. So I'm going to write f of x equals, I'm looking to factor both of these quadratic trinomials. So the first one, I need factors of negative 45 that add to 4. That's x plus 9, x minus 5. And then I need factors of negative 30 that add to 1. That's going to be plus 6 and minus 5. And you'll notice my common factor is the x minus 5. So I will have another whole here. So I'm going to write x plus 9 over x plus 6. Again, please, 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 please do not try to reduce those. They're not, that's not possible, right? These are factors. Put parentheses around them if you need to. All right, let's do the domain, right, before we crossed out. Negative infinity, comma, negative 6, whatever makes my denominator 0. Negative 6, comma, 5, and then 5, comma, infinity. Oh, come on. There we go. Good enough. Y-intercept, I'm going to plug into what's left, which is 0 plus 9 over 0 plus 6, which is 9/6, which reduces to 3/2. X-intercepts, remember, set the numerator equal to 0 of your, after you fully factored. So I have x equals -9 or -9 comma 0. Vertical asymptotes set the denominator equal to 0, so I get the same vertical asymptote as before, x equals -6. My whole, the common factor was x minus 5, so the whole will be when x is 5. Don't forget to plug that back in to what you have left, which is going to be 5 plus 9 over 5 plus 6, which is 14/11. So your whole is at 5 comma 14/11. And in terms of the horizontal asymptote, this time they have an equal number in terms of the powers, right? Both of those are to the first power. So this is the leading coefficient over the leading coefficient. Both leading coefficients were 1, so it's y equals 1. All right, so putting these on there, I have y equals 1 for the horizontal asymptote, x equals -6 for the vertical asymptote, 5 comma 14/11, so 5 and a little over 1. It's going to be the whole. Excellent. My y-intercept was 0 comma 1.5, which is 3/2. X-intercept was -9, 0. Just going to be down here. So that should help me graph this, since my x-intercept is on the other side. All right, so there's that part of the curve, and then this one right here. All right, and that is it for the second graph. Okay, I said I was going to do some exponent rules to finish off this part of the video to get us ready for our work with radicals. All right, so let's simplify some of these, and then we'll be finished. So anything to the 0 power, right? This whole thing is being raised to the 0 power. It's just going to be 1. So this is just going to be x to the 4th power cubed. For this one, we've got options here. I'm going to go ahead and deal with this cube first. So I'm going to get 8, which is 2 cubed. U cubed raised to the 3rd power is u to the 9th. W squared to the 3rd power is w to the 6th power. Down here, I can add these together and get, I'm going to get u to the -1st power, v to the 4th power, and then w to the 5th power. So simplifying now, if I start with my u's, I'm going to end up having this -1 down here really needs to move across, right, to be a positive 1. So that's u to the 10th. My v is going to stay down here, v to the 4th power. That's the only one I have for v. And then when I look at the w's, the way my brain does it is 6 is bigger than 5 by 1, so I'll have w to the 1st power up top. All right, that is it for letter B. Okay, let's keep going. Let's go to letter C. All right, letter C. Again, you can deal with the numerator, then the denominator. That's what I like to do. So 2 times 4 times 3, that's going to be 8 times 3, which is 24. And then I have x squared, and x to the 1st power. So 2 plus 2 plus 1 is to the 5th power. Y to the 4th power times y to the 4th power. You add the exponents and get y to the 8th power. And then this one, I have 3 y squared. I'm going to move this x to the -3rd power up to be x to a positive 3rd power. Okay, so then I have 24 over 3 is going to reduce. It's going to give me 8. X to the 8th power. All right, oh, look at this. I don't even need to have a fraction bar because if you look at my y to the 8th power over y squared, that's going to be y to the 6th power. All right, let's go to letter D. Now, whenever you have something raised to a negative exponent, you can write it as 1 over that same thing to the positive exponent. So I'll write this as a times c to the 4th power over 2ac to the 4th power raised to the 3rd power. So I change it to a positive 3. So dealing with that denominator, I get 8, right? 2 cubed is 8. A to the 3rd power is a cubed. And remember, a power raised to a power you multiply. That's going to be c to the 12th. So to finish this, I'm going to have 8 in the bottom. This is a to the 1st power. So that's 2 a's left on the bottom. That's 8 C's left on the bottom, so nothing on the top, so I put a 1. All right, let's go to E. All right, similar idea where I put 2m cubed to the nth, or times n on top. This whole thing I'm going to put on the bottom because it's a negative exponent. So 2m to the 0 power n squared raised to the positive third power. So 2m cubed n over, that's 8. M to the 0 power, anything to the 0 power is just 1. So 1 cubed is just 1, so I'm done with that. And then n squared cubed, you multiply 2 times 3 and get 6. So that's going to reduce to 1/4. I have m cubed on top. You can put a 1, but you don't have to put a 1 in front. And then when I look at my n's, that's n to the first power, n to the 6th power, so I have n to the 5th power in the denominator. All right, let's do F, and then I am finished. All right, anything to the 0 power. So this whole thing is raised to the 0 power. So that's going to become a 1 over 2a to the negative 3rd power, c to the negative 4th power, d to the negative 2nd. And I've told you guys that if you have negatives, you can move them across the fraction bar and they become a positive. The tricky part here, guys, is that this 2 is not connected to any negative power. So that 2's got to stay down. Let me erase this. That 2's got to stay in the bottom. And then a would become a cubed, c would become c to the 4th power, and d would become d to the 2nd power. Okay? So that is it for this video on some graphing, and then we did a quick little refresher on some exponent rules. The next video up is going to begin the work on Unit 7 on radicals.